So if you've been programming in C for a while, you probably know that string handling is quite difficult and tedious. But today I want to show you guys an alternative approach to string management in C, which is length-based strings. Now let's say I've got a string here called hello world, and I want to know how is this string represented in memory. Well, what actually happens is, in this case, it's a string literal, so it's stored in the data segment of our binary. But this also applies to strings which have been allocated in the heap. They all are stored something like this. So I'm going to have a piece of memory, and inside of it I'm going to have an array which is going to contain the string. So here I've got hello and world, and at the end right there I've got a null-terminator. Now this null-terminator is usually hidden from the programmer, but this is how C knows what the C runtime knows what the end of the string is going to be. It just searches for a null-terminator. Now the problem with the null-terminator is it's quite annoying to deal with because it's very easy to slip up, and then you can get a lot of very annoying bugs. So to show you guys what I mean by that, I'm going to change the string to this one. So let's say a string, and let's say I want to create two substrings from it. So I want to take substring a and then create another make another substring string. I'm going to create two copies of those. How can we do that? Well, the first step is we need to first have a pointer to the start of the string, right? Because we're going to start reading from it. The next thing we have to do is add a null-terminator after a. Now what's going to happen is when we start using some kind of string function from the standard library, let's say strcopy, it's just going to take our pointer and then continue reading bytes until it finds a null-terminator. So in this case, if it starts reading bytes from pointer, it's going to read a, it'll reach a null-terminator, and then it'll just stop copying bytes from there. Now, if we want to copy string, we have to move our pointer 2 bytes forward to the S character, and then we can run strcopy again to get the second string. Now, let's say this string was allocated on the heap, which it is because we're modifying it. One of the problems you might notice is this is actually unsafe to call free on, because if you call free on the pointer for this allocation, is undefined behavior, because malloc expects you to call free on the exact memory address that it gave you. So like if I got a pointer at a, it expects me to pass a pointer back at a to free. So if I try calling free here, which we can do accidentally, that's undefined behavior. We can get some bad behavior from it. So what we have to do in this case, if you want to free the memory, you have to move the pointer back to a. And then if I also want to, let's say, read the string again, I have to remember to turn the null-terminator back to a space. So it continues reading across A. So as you can see, there's a lot of little moving parts inside of null-terminated strings, which are very annoying to deal with. And if you forget something, you can have undefined behavior, you can have crashes, or it might just not behave as you want it to. So what's the alternative to this approach? Well, we've got length-based strings. With length-based strings, we don't have to worry about the null-terminator, because we're not going to be thinking in terms of read bytes until this point. We're going to have a fixed size. So to show you guys what I mean by that, in a length-based string we have two components. We have a pointer to the string, and then we have a length. So in this case, the length of this string is 8. We can represent this whole string with just those two pieces of information, the pointer and the length. Now let's say I want to go back to the example before of creating two substrings. So in order to create the second substring, I'm just going to make a pointer to the other part of the string I want to read from. So I have one pointer at A, the other pointer at S, and then I can just specify the length of each of these strings. So for the first pointer, the length is 1 because there's one character, and for the second pointer, the length is 6. So what's going to happen is, when we try to use some of our string functions, we're just going to go to the pointer, let's say pointer 2, and we're just going to look at the length. That's going to tell us how many bytes we need to read. So we just read 6 bytes ahead. And this makes it a lot easier to do a lot of string operations, because we don't have to worry about changing the string and then changing it back to its original state. And this makes it a lot nicer to work with. Now one thing is that I like to create length-based strings, or rather I like to set length-based strings to be immutable. What that means is once a string has been created, I can't modify it. So I can't modify the memory in it. So it's like a string literal in that sense. So that means that whenever you want to make a change to a string, make a copy of it, or like a substring, you have to clone the string, which you might think is not ideal because, you know, creating a copy for the string for every small operation is probably slow, is not efficient. But modern computers are extremely fast, and having a bit of convenience for the sake of speed, I think it's worth it, especially in the long run. And also, this kind of approach of immutable strings and length-based strings in general. So here I've got a piece of code. So we're going to have a simple thread context which contains arenas, and then we're initializing the arenas here. So I've actually separated the logic for the arena into two separate files. I've got this header file I'm just going to use, and I've created some macros I like to use to interact with the arenas, and then I've got the implementation right here. Now, if you aren't familiar with arenas, I recommend that you go back to my channel and look at my series about arena allocators, because length-based strings and arenas go hand in hand if you want them to, because they work really well together. So I'm going to show you guys how we can create a basic setup for a length-based string. So the actual string itself is very simple. I'm just going to create a struct. I'm going to call it string. It's going to have two components. It's going to have a pointer to a string, right, the actual buffer. It's going to have a length as well. That's it, right? So just two pieces of information, a pointer and a length. Now, let's say I want to do something like append two strings together. How would I do that? Well, if you remember, I told you that once we created a string or a length-based string, it's immutable, so you can't change it. So if I want to append a new string, if I want to append a string to a already existing string, then I have to just create a new string for that. So if I want to do something like string append, I'll pass an arena where I'll do the allocations. And you'll see why I'm saying that arenas work really well with these kind of strings. I'll say original string, which is the first string you want, and I'll say the append string, right? Now, if we're doing something like this inside of the, if you're doing something like this with null-terminated strings, it's not that difficult, because all you have to do is just use the standard library just to copy the bytes in, but you have to be careful not to copy in the null-terminator, otherwise you won't be able to read all the data. With length-based strings, it's also very simple. So we're going to first create the string length. So I'm going to say that's going to be original string.len plus append string.len. This is the size of the new string. Then I've got to allocate memory for the new string. So I'd say push string, which is a macro I like to use, and then I'm going to pass in the arena, and then I'm going to pass in string len, right? Then I can just use memcopy to copy in all the bytes from the original string. Now, since these strings right now are in ASCII, they're all 1 byte long, so we can use memcopy. But if you got like UTF-8 characters, then I think you probably have to use something else. I'm not sure if you can use memcopy, because memcopy does like byte by byte. But I'm not fully sure. We're gonna have to check that stuff. But for ASCII, in this case, we can just put in buffer. Then we're gonna pass in the original string, and then we're gonna pass in original strings length. And then what we can do is offset by the first string, the length of the first string. So here I've copied in the first string, then I'm just moving the pointer of buffer. So I'm just adding the original string's length, so we can just append onto the end of it. So here I'm going to pass in append string dot string and then append string dot len. Then all I have to do then is just return a string, right? So I can just do return string, pass in the buffer, and then string len, right? That's all we need for that. So if I try compiling this, right, it runs. Okay, it works fine. So if I want to actually use this, so how can I create a string? You might be asking, well, if I create a heap allocated string, that's fine. But if I want to use a string literal, I'm going to create a macro for that. So I can say here, define strlit. I'll pass in a string, and this will just return to us a struct where s is a string, and then I'm going to do size of s minus 1. Now, one of the nice things about string literals is that they're encoded in the binary, so we know their size at compile time. So you can use the size of operator to get the size. However, size of also includes a null-terminator, which you don't want. So just minus 1 from that to get the actual length of the string. So then what I can do here is, let's say string first string is equal to strlit. Let's say first. Now say string second string is equal to strlit second. And then let's say I want to append these two strings together, so create a new string. I'll say string third string is equal to string append. I'll pass in my global arena. Then I pass in the first string, then the second string. right? And then if I quickly build the code, compiled, okay. So let's say I want to print out this string right here, the third string. How can we do that? Well, there are two approaches we can take. Either A, we can create our own printf function, which is probably quite difficult because there's a lot of things you have to handle with printf, or we can just turn our length-based string into a C string, which is quite easy because all you have to do is create a new buffer for it, just copy in the string, and then just add a Null-terminated at the end. So we can do that pretty easily right here. So if I do something like string, or rather child pointer, string to C string, pass in my arena, then I pass in the string I want to turn into a Null-terminated string. I'll just create a child pointer, C string is equal to push string arena string dot len, right? Just gonna mem copy all of our data from the original string into there. Then we just add an Null-terminated at the end of the string. So to start indexing from 1, we can just use string.len. When we start indexing from 0, we can just use string.len because the character is going to be empty at the end. Then just return C string. So now I can do something like printf string to C string third string. I forgot to pass in my arena. Okay, there we go. We've got the string being printed out. That's pretty nice. So, like, what other stuff can we do with strings? Well, I'm going to create a few more helper functions, which is going to be called string range. So, actually, no, it's not string range, string compare. So, you're probably used to strcmp. This just sees if two strings are equal. We can do the same thing with our length-based string. So, all we have to do is just say string comp. I'm going to pass in the first string. I'm going to pass in the second string. The reason I'm not passing in an arena here is because we're not creating any new strings, we're just comparing existing strings. Now the thing is, we don't actually have to compare all the characters, so this can be quite fast. So normally with Null-terminated strings, you have to go through all of the bytes in the first string and then compare them with all the other bytes in the second string. And then if they're equal, it's fine. If they're not equal, we get information about what the differences are. But the thing is, we know that if two strings aren't the same length, they can't be equal, right? Because they need the same number of bytes to be equal. So in the case that the first string's length is not equal to the second string's length, we can just return false immediately because we know that these two strings can't be equal. So in that case, this can happen really fast. So in the other case that we actually have two strings which are equal, we can start comparing them. So let's say for int I is equal to 0, I is less than first string dot length because we know the length of the string. Then I'll go to the other string, I'll compare it to the other string, so say first string dot string at I is not equal to second string dot string at I. So in the case that a certain character and these two strings are equal, I'll just return false immediately. And if you get down here, we can just return true, right? So if I do something here like, let's see if the first two strings are equal, so I say string comp. I'll say first string, second string, and then build this. If I run it, okay, those two strings are equal. But if I create another string literal right here, so I'll say first, that's a bit strange. I think that should work. That's a bit strange, so I'll just create another string here then. So this should compile. Okay. So we got one for that, so these two strings are the same. Now, another thing we can do is create substrings or extract substrings from a string or from a length-based string based upon indexes. So what I mean by that is, let's say I've got a string range, right, I pass in a reader for this, I have a string. So I have a start position, then have a end position. And what I can do is I can just create a pointer to this existing string with the length being end pos minus start pos if it's valid. So what I mean by that is, if the end position is greater than the start position, that's an invalid value. Or if the start position is greater than the wrong way around, end pos, or if the start end position is greater than string background. So in these two cases, these two indexes are invalid, so just return an empty string, I guess. Right. Otherwise, we can just return a string, and what we're going to do is we're going to do string.string plus the start position, right? Then the length of the string is going to be end pos minus start pos. So what this does is that it creates another pointer into the string and just gives us a little slice of it by just changing the length. So let's say I've got a string right here. I'll change first string to a string, right? And then if I do something like printf I'll do string range, I'll pass in my arena, and then I'll pass in my first string, which is going to be first string. Then I want it from indexes, right? So let's say 2 till the end. So I'll just say 2 till first string dot length, right? And then I have to turn this into a C string for it to work. If I run this, right, we get this little substring right here called a string, and this is inclusive, so it won't include the last index, it includes the character just before. So that's pretty cool. Now let's say I want to do something more complex. I want to create a function which takes in a string and then it just separates it based upon whitespace. So if I've got like 10 words in there, it will give me an array of like 10 words which I can then use wherever I want. So how can we do that? Well, the first thing is we have to create a function for that. We need a way to represent these different structures. So like, how can we represent an array of strings? So we can say typedef struct string, right? We're gonna have a string here. Then we have a string node, a pointer to the next string node. Right, then I'm just gonna create a little function struct right here to hold it. So say node. Anyway. So this is a linked list which contains a bunch of string nodes. It's just strings, right? So we can just store as a linked list because we don't know how many words there might be in the string. So then the first thing we need to do is just create the function for actually doing all of that. So let's say right here, string array, string sep on Whitespace arena. We pass it our string, right? So the first thing is we might have a string like, let's say we got, I'm going to change this, so say a string which contains a lot of whitespace around the edges. So in this case, if separating on each white space, we'll get stuck around the starts and edges start and ends, because we have a bunch of white space right here. So what we can do is we need to first remove the white space at the start and the end of the string, such that when we start reading the string from the start to the end, there's going to be a character there. So I'll create another function right here. I'm going to call it string trim white space, right? I'm just going to pass in a string. Then what this string's going to do is going to move the pointer at the start and then just change the length, so we can just crop out the white space at the start and the end. So don't have to actually create a new string for this. So we can do something like start index is equal to 0. Then I'll say for int I is equal to 0, I is less than string.len I++. So if string at I not equal to, this means that we found the starting index of so we found the index of the first character in the string, which is not a space. So we can just say start index is equal to I, just break out the loop. Right, now for the ending index, so say the last character in the string, which is not a white space, so we can just say end index is equal to 0, right? So for int I is equal to 0, I is less than, actually we're going to reverse it, so we're going to start iterating from the back of the list. And we have to do -1 because we start indexing from 0, right? So string len is actually a valid character, just tell us how many bytes there are, but we have to do -1 to get to the end of the string. So I'll say I is greater than start index, right? Because if we don't have start index and we do something like 0, we might just end up chopping the string backwards, so that we just chop the string at the start. So we're gonna have to add start index right here to avoid that. So I say string.string at I is not equal to space and index. Now what we can do here is just return the new string. So say to return string.string plus start index, and then end index minus start index. That would give us the length of the string. So let's show you guys how this would work. I'm just going to comment this out. So if I do something here like printf, actually if I just take this right here, if I print out the first string right now, right, so right now we've got white space all around the string. So how can we remove that? What we can do is, let's print out the string again. What we're going to do, string trim white space, and it removes all the white space around the edge. And I accidentally removed a character at the end. I'm gonna fix that. There we go, we got the last character there. So now that we've got this function to remove all the white space, we can start doing the rest of it. So the first thing is string trimmed string is equal to string trim white space. I'll just say I'm gonna pass in our string right here. So how can we separate all of these words in the string based upon the white spaces between them? What we can do is we can just go through all of the, now that we know that the starts and the ends of the string don't contain any white space, we can just go through each of the different characters. We can iterate over the string and just check for white space, and then we can just create a substring from there. So I'll show you guys how we could do that. So I'm going to create a string array right here, and then the first node is going to allocate some memory for it. If you guys are wondering where these macros are coming from and the word syntax for them, is actually from this arena.h header file right here. So I've got a bunch of these little macros I like to use just to interact with the arena alloc function. It just makes it easier mentally to think about how I do the allocations. So you can just use arena alloc here as well, but if you want, you can also use these macros I wrote right here. I'll leave it all down in the description with the rest of the code. So what we can do here is create a string node. I'll say current node, because we'll iterate over this linked list as we create it. So I'll say for int I is equal to 0, I is also create another integer right here called previous index, previous start was, that's also 0. So if the trimmed string at index I is equal to a space, then we know that we've got to a word. Now what previous start pos does, it just tells us the previous start position of the last string. So in this case is at 0. When we reach, let's say, our first white space at 2, we can just do I minus previous start pos, and that will tell us the length of the string, right? So I can do something here like uint64t string len. I'll do I minus previous start pos, which will tell us the length of the string. Then let's allocate a buffer. So I'll create copies for all of these little substrings. I'll say arena string len. Right. So just mem copy into buffer, the trimmed string, and the previous start position. Then do string len. Then the current node, the string is going to be this string right here. And then I can also say current node, the child node, I'll just allocate some memory for that. And then I'll say the current node is equal to the child node. And then we also have to set the previous start position to be I plus 1. We do plus 1 because currently I is at a white space, so we have to just add 1 to get to the next character. So once we do that, we can just return the array, I guess. Then we can just, we'll see if it worked. So I'll say, let's just quickly create an example of printing all this stuff out. So send him a string, okay, first string. Let's say for string node, innovate, so we're going to start off there. And then as long as we have a child node, just continue iterating over the list. So what we can do here is we say printf string, let's say length. So what we can do is we can just get the C string for it. So say C string ctx.global arena node string, and then also get the length, which is going to be node string dot length. So if I build the code quickly, it compiled, let's run it. And as you can see, we got pretty much all the characters there. I mean all the words except one, which is the last character. I mean the last word right here, word. I mean end. So the reason that happens is because if I quickly go down here, so here we didn't get end. In this function, the last character in the we always start copying strings when we see a white space, but we don't have any white space at the end of the string because we just removed all of it at the start, right? So what we can do here, we can just say, okay, we can copy this if statement, put that right here, and then say if I is equal to, let's say trim string dot len minus 1, right? We can just copy the string again. So let me see if this works. Okay, we didn't get the last character. That's not gonna use it. Okay, we can get the string from this way. But you can add another if statement to see if we're at the end of the string, then we just copy the last word there. But another way we can do it, which I think is a lot cleaner, is just add a string at the end, just append a string. So we just say string append, we can append a whitespace. So we say arena, then I just pass in a whitespace right here. So if I do go to now, that's a bit strange. Oh, I'm adding a note, I'm adding a colon there. And there we go, we get the last character there. So I hope I showed you guys how useful and well, quite nice length-based strings are. They're a lot easier to work with than null-terminated strings. And if you want, I showed you guys, you can create your own string API really easily just with using length-based strings. So I hope you guys found this video useful. If you're struggling with arenas and trying to understand how they work, I've got a series on arena allocators, which as you can see they work really nicely with length-based strings. So I highly recommend you check that out, and thank you for watching the video. I've got the source code in the description as always, and I'll see you guys later. Bye.